Picture a nation once locked out of the world's greatest orbiting laboratory, told there was no room at the table. That nation didn't beg for a seat on the International Space Station. It built its own house among the stars. This is the story of how China went from watching rockets on television to commanding its own space station. It's a tale of ambition, secrecy, sacrifice, and one of the most stunning engineering feats of the 21st century.
In the early 1990s, China wasn't even a serious player in human spaceflight, let alone a station builder.
The Soviet Union was gone, America ruled orbit, and China's own rockets had barely left the launch pad reliably. Yet inside a closed-door meeting in 1992, Chinese leaders quietly approved a plan that would take 3 decades to finish. They called it Project 921, a code name hiding one of the boldest space ambitions on Earth. The goal wasn't just to send a man into orbit. It was to eventually build a permanent home there. Western nations barely noticed, distracted by space shuttles and the birth of the International Space Station. In fact, when the ISS was being designed, the United States made sure China had no invitation to join. A 2011 law effectively banned NASA from partnering with China, citing national security concerns. Instead of protesting, China's engineers simply nodded, turned around, and got to work on their own destiny. What followed was a slow, methodical climb that surprised almost everyone who underestimated it.
It began, as most space stories do, with a single human being strapped into a capsule.
In October 2003, Yang Liwei became the first Chinese astronaut to reach orbit aboard Shenzhou 5.
He circled Earth 14 times in 21 hours, and China instantly joined an exclusive club of spacefaring nations.
Overnight, Yang became a national hero, his flight broadcast to hundreds of millions of proud citizens.
But this was only the opening chapter, a single brick in a much larger structure. Chinese planners knew that landing one astronaut in orbit was nothing like keeping people alive there for months. So they set their sights on something harder, docking 2 spacecraft together while circling the planet.
In 2011, China launched Tiangong-1, a small experimental module barely bigger than a school bus.
It wasn't a space station yet, but a rehearsal stage, a place to practice the moves. The name Tiangong means Heavenly Palace, a fittingly poetic title for a program built on patience. The following year, Shenzhou 9 carried 3 astronauts to dock with Tiangong-1 successfully.
Among them was Liu Yang, the first Chinese woman to fly into space. Engineers on the ground held their breath as the 2 spacecraft inched toward each other in the dark. Docking in orbit is like threading a needle, while both the needle and thread are hurtling at thousands of miles per hour. When the hatch opened and the crew floated inside, cheers erupted across Chinese mission control. It proved that China could not only reach orbit, but also connect structures while up there.
Tiangong-1 eventually became a ghost station, quietly decommissioned, before falling back to Earth in 2018.
Rather than mourn it, China had already moved on to its successor.
In September 2016, Tiangong-2 launched, a more advanced laboratory built for longer stays. Astronauts lived aboard it for 30 days, testing life support systems that would later matter enormously. They grew rice and other plants in orbit, studying how life adapts beyond Earth's atmosphere. Every mission added another page to an engineering playbook, yet nobody was allowed to borrow from outsiders. Because of the American ban, Chinese scientists had to solve nearly every problem from scratch. That isolation, oddly enough,
became a strange kind of fuel, forcing total self-reliance. While other nations shared blueprints, China built its own docking systems, its own life support, its own everything. By the late 2010s, the pieces were finally coming together for something far larger than Tiangong 2. Engineers began assembling the core module of what would become a genuine, permanent space station. They named it Tianhe, meaning harmony of the heavens, a name chosen with obvious symbolism. Tianhe would serve as the beating heart of the entire station, housing crew quarters and control systems. But first, China needed a rocket powerful enough to lift something this massive into orbit. Enter the Long March 5B, a heavy-lift rocket built specifically for hauling space station modules. It was, at the time, one of the most powerful rockets China had ever built. On April 29, 2021, the Long March 5B roared off the pad, carrying Tianhe into the sky. The 22-ton module was the largest single spacecraft China had ever launched into orbit. As it separated and unfurled its solar panels, engineers across the country watched their decades of work take shape. Tianhe reached orbit successfully, becoming the anchor point for everything that would follow. It measured about 54 feet long, roughly the length of a large school bus stretched out in space. Inside, it held sleeping compartments, a bathroom, exercise equipment, and a robotic arm control station. That robotic arm would later prove essential for maneuvering modules and even catching visiting spacecraft. Just weeks later, China launched Tianzhou 2, a cargo ship packed with supplies and fuel. It docked automatically with Tianhe, refueling the fledgling station without any human hands involved. Then came the moment the world had been waiting for: actual astronauts moving in.
In June 2021, Shenzhou 12 launched 3 taikonauts toward their new orbital home.
Nie Haisheng, Liu Boming, and Tang Hongbo became the first residents of China's own space station. They spent 3 months aboard Tianhe, testing systems and even performing spacewalks outside the module. Watching from the ground, Chinese state television carried their every move to a captivated public. For the first time, China had sustained a crewed presence in space entirely on its own terms. But Tianhe alone wasn't the finished vision. It was only the trunk of a growing tree. 2 more branches still needed to be attached before the station reached full size. Those branches were named Wentian and Mengtian, each a science laboratory in its own right. Wentian means Quest for the Heavens, a module dedicated to biological and life science experiments.
In July 2022, another Long March 5B thundered into the sky, carrying Wentian toward orbit.
It successfully docked with Tianhe, adding new lab space and even a backup control center. Wentian also carried an airlock designed specifically for frequent, efficient spacewalks.
3 months later, its twin module, Mengtian, followed, meaning, dreaming of the heavens.
Mengtian focused on physics, material science, and experiments needing a stable microgravity environment. When it docked in October 2022, the station's basic T-shaped structure was finally complete. From a distance, the finished Tiangong resembled a plus sign, 3 modules fused into one home. It weighed roughly 100 tons, smaller than the ISS, but undeniably a serious achievement. China had gone from a single orbiting capsule to a multi-module station in under 20 years. Engineers celebrated, But the real test was proving the station could function continuously, not just assemble. That meant keeping a permanent, rotating crew living and working aboard it around the clock. Chinese mission planners designed a system where new crews arrive before old ones depart. This handover approach ensures Tiangong is almost never left completely empty. Shenzhou spacecraft now launch roughly every 6 months, ferrying fresh taikonauts to the station. Each crew typically spends about 6 months living, working, and running experiments in orbit. Inside Tiangong, astronauts sleep in private cabins with tiny windows overlooking the curve of Earth. They exercise for hours daily, since muscles and bones weaken quickly without gravity's constant pull. Meals include rehydrated dishes, and yes, plenty of traditional Chinese cuisine adapted for orbit. Reports have described dumplings, rice dishes, and even mooncakes shared during holidays in space. Video calls let taikonauts speak with family back home, bridging hundreds of miles of empty space. Every so often, they broadcast science lessons to school children watching eagerly across China. These orbital classrooms have become wildly popular, inspiring a new generation towards science and engineering. Tiangong also hosts genuine scientific research, not just symbolism or propaganda for television cameras.
Experiments range from combustion studies in microgravity to growing plant seedlings for future food security.
Some research focuses on how human cells behave differently without Earth's gravity constantly present. Other experiments study advanced materials that could someday improve batteries or manufacturing back on Earth. Outside the station, a suite of instruments monitors cosmic rays and studies deep space phenomena. China even built a separate telescope, called Juntian, designed to fly alongside the station. Though not physically attached, it can dock periodically for maintenance and battery servicing. Juntian is expected to survey vast portions of the sky, rivaling capabilities of the Hubble telescope. This cooperative design, station plus telescope, shows how ambitious China's long-term orbital plans truly are. Meanwhile, back on Earth, the International Space Station is aging, its components decades old. NASA and its partners plan to retire the ISS sometime around 2030, deorbiting it into the ocean. When that happens, Tiangong could become the only continuously operating space station left in orbit.
That possibility alone has reshaped conversations about the future balance of power beyond our atmosphere.
Some American officials have expressed concern about ceding orbital presence entirely to a rival nation. Others argue competition simply pushes both countries toward faster innovation and bolder achievements. Either way, China's exclusion from the ISS now looks less like punishment and more like motivation. Ironically, being locked out may have accelerated China's independence, rather than slowing it down.
Chinese officials have repeatedly said Tiangong is open to international cooperation, unlike its own experience.
Astronauts from other nations have reportedly trained in Chinese facilities, learning the language and procedures.
Packages of experiments from countries like France, Italy, and others have already flown aboard the station. This outreach positions China as an alternative partner for nations left out of NASA-led programs. It's a quiet but deliberate contrast to the isolation China itself once faced from the West.
Back in the 1990s, few could have predicted this reversal of roles in orbit. The engineers behind Project 921 are often unnamed, their work classified for decades under state secrecy. Yet their fingerprints are visible in every successful docking, every safe splashdown,
every completed spacewalk. Spacewalks themselves have become almost routine, with taikonauts venturing outside to install new equipment. Each suit is a marvel, custom-built to withstand extreme temperatures and vacuum conditions. China's own spacesuit design took years of testing before astronauts trusted it fully outside the hatch. Robotic arms extend from Tianhe and Wentian, helping astronauts move safely along the station's exterior. These arms can also capture and relocate modules, a technique refined over multiple missions. Ground controllers in Beijing monitor every heartbeat, every oxygen level, every system reading in real time. A vast network of tracking stations and ships helps maintain constant contact with the orbiting crew. Even during launch, recovery teams stand ready across Inner Mongolia's vast grasslands for the capsule's return. Shenzhou capsules parachute down and often tip onto their side, cushioned by crushable landing struts. Recovery crews rush toward the smoking capsule, extracting astronauts who sometimes need help standing again. Months in microgravity leave the human body disoriented, adjusting slowly to gravity's stubborn return. Despite the physical toll, applications to become a taikonaut have surged among young Chinese citizens. The program has even selected its first crew members, hailing from Hong Kong and Macau. This inclusion signals an effort to make the space program feel like a truly national project. State media frames each mission as proof of China's rising technological and scientific stature. Whether or not one agrees with that framing, the engineering results speak for themselves. Building a space station requires mastering rocketry, robotics, life support, and orbital mechanics simultaneously. Very few nations in history have managed to combine all four disciplines this successfully. The Soviet Union did it with Mir, the United States and partners did it with the ISS. Now, China stands as the third nation to independently sustain a long-term human outpost in orbit. That milestone alone reshapes assumptions about which countries will lead space exploration in coming decades. Chinese officials have also announced ambitions to send astronauts to the moon before the end of the decade. Tiangong, in that sense, isn't a finish line but a stepping stone toward deeper space goals. Engineers are already testing technology that could eventually support lunar landers and surface habitats. Some analysts believe a new space race is quietly forming, echoing the Cold War-era rivalry. Unlike that earlier race, this one involves permanent infrastructure already circling the planet right now. Tiangong isn't a one-time flag-planting mission. It's a functioning home meant to last for years. Its expected operational lifespan stretches at least a decade, with potential for further extensions. Chinese engineers have hinted at future modules that could expand the station even further.
If realized, Tiangong could grow larger, hosting more crew and more ambitious experiments over time.
For American audiences, the story raises an uncomfortable but important question about long-term strategy.
What happens when the only continuously staffed space station belongs to a strategic rival nation? It's a question without an easy answer, tangled in politics, budgets, and national pride.
Yet beyond geopolitics, there's something undeniably human about this entire journey into orbit. It's the story of engineers solving impossible problems without the blueprints everyone else had access to. It's the story of a nation once excluded, choosing to build rather than beg for entry. It's the story of ordinary people becoming taikonauts, floating above the planet their grandparents once dreamed about. Every docking, Every spacewalk, every harvested seedling represents thousands of hours of quiet, unseen labor. From Yang Liwei's lonely 14 orbits in 2003 to a fully staffed station today, the leap is staggering. 2 decades transformed China from a spacefaring newcomer into a serious, independent orbital power. And it happened almost entirely outside the spotlight most Americans were watching at the time. While headlines focused on SpaceX rockets and NASA's return to the moon, Tiangong quietly took shape. Now, orbiting roughly 205th miles above Earth, it circles the planet every 90 minutes. Inside, its crew watches 16 sunrises and sunsets every single day, a rhythm unlike anything on Earth. They tend experiments, exercise dutifully, and occasionally just float, staring down at the blue planet below. Whatever geopolitical debates rage on the ground, up there, it's simply humans living somewhere new.
Tiangong stands as proof that being excluded from one table doesn't mean you can't build your own.
And as it orbits silently overhead tonight, it's a quiet reminder that the next great space story is already being written.